Yes. So hello, everybody, and welcome to our analytics and data techcast today. We're going to have a great presentation today with about the new feature of having Graph Studio in Oracle Autonomous Database. We're going to have a presentation by Hans Viehmann, product manager at Oracle. He's based on Germany, and he has huge, I don't know how many years of working as a product manager for Graph and Spatial at Oracle. We also will have Jayant Sharma, which is Senior Director of Product Management at Oracle. But before going deeper into this session, I'm going to share with you something about our community and our Techcast. So as you probably know, we have this Techcast and we are going to having more Techcasts for this year. The main one that we are having after that is the one that we are going to talk about the new features in Oracle Analytics on April 8th, presented by Dan Blamis. And if you want to check all the other Techcasts that we have done in the past, you can go to our YouTube channel or visit our website. And in fact, we are always looking for new content. So if you have something that you want to share with us, some knowledge, some experience, some specific business case that you want to share with us, just submit an abstract in our website, and we're going to review it and be in contact with you. But one important thing is what we have Techcast Days that we're having every single quarter. And the next one is on May 11 to 13. And we're going to have hands-on labs this time for all the topics that we usually talk in our analytics and data community, which is graph and spatial, analytics, and machine learning. So keep in touch, and you can register right now. One important thing is that the community is growing every moment. And one important thing that we have done is create a Slack channel to be in contact. And a community is, for me at least, is a perfect way to share, to learn, and to be part of something bigger than just us. So if you want to be in contact with us, just we're going to share with you the invitation for the Slack channel that we have. So we are going to share some, you can share some questions, you can share some experience that you have. We have also a newsletter with many information about our analytics and machine learning and graph and spatial topics. You can follow us on LinkedIn, on Twitter, and in Facebook. And this session is going to be recorded. So there's the presentation, the slides, and the recording is going to be shared in our website. Hans? One important thing before going into the topic, please submit your question into the Q&A box, not in the chat, please. So all the questions are going to be answered, after Hans and Jayant ends with his session, with their session. So Hans, the audience is all yours.
Yes, thanks, Adel. It's a great pleasure for me to spend the next 40 minutes or so with everyone on the webcast. Let me just quickly share my screen. Here we are. Hope that works. Can everybody see my screen?
Yes.
Good. Excellent. So thanks for the introduction, Ada. My name is Hans Viehmann, as Ada was just saying. I look after the outbound product management team for the spatial and the graph technologies. And today we'll be talking about Graph Studio in Autonomous Database. And that's, from my perspective, a very exciting moment. I don't know if you had a chance to listen to Andy Mendelssohn's webcast last night, but he formally announced the availability of Graph Studio, or he said we are going to make it available, generally available in the next few weeks. We currently have a limited availability program. So that was the official announcement of Graph Studio. You may have seen press release and blog on Database Insider and so forth. So we got some coverage, and it's a great pleasure for me to share the tool and the details about the tool with you. And I'm not alone on the webcast. I have Jayant with me. Jayant, do you want to say a few words about yourself also?
Sure. Thank you, Hans. So I'm a colleague of Hans on the product management team looking after spatial and graph. I've been working on the Graph Studio, the portion in the autonomous database that of late, that's been my focus. And we hope this will be an informative and productive session. So back to you, Hans.
Yep, thank you. And in the background, we have Jean and Melly working on the chat and on the Q&A as well. So if you have any questions, do submit them in the Q&A box. If they can be taken care of quickly and easily, Melly and Jean will take care of them. If they are maybe a good point for discussion, we may find some time at the end of the webcast to go over the Q&A, Jayant and I. In the live session. Right, so without further ado, let's actually get started. As we're talking about a product or a service which is not yet generally available, here's the safe harbor statement, just so that everybody's aware, right? Do not base your purchasing decisions on what Jayant or I are saying. Everything may be very different next week or the week after, but you know, we're getting close to GA, so I don't expect to be too many differences to still crop up. Right, so let's take a step back first of all and start with what graphs and graph databases are all about in the first place. I don't know if you've been looking into graph databases and graph analytics recently, but it is an increasingly popular topic. It's got nothing to do with pie charts or bar charts or graphs like that, but what we are referring to are graphs where we are representing entities as vertices in a graph and edges as the connections between them. So many people associate social networks with graphs, right, where you have people as the vertices in the graph and the connections between the people as edges. And then using graph analytics, you know, you can do analysis specifically of the relationships. So you can easily identify people with many connections, or you can identify people who are connected to people who have many connections. Or I don't know if you know the 6 Degrees of Kevin Bacon game, right? You can find indirect connections between people. Is this person connected through so many hops to Kevin Bacon or some other person? These are typical questions you can answer very nicely using graph databases. If you want to do more sort of complicated algorithms, people also use graph databases for the purpose of community detection, right? Finding those parts of the graph, like in the little picture here on the right-hand side, finding those parts of the graph which are more closely interconnected than they are connected to the rest of the world. Or if you have two communities here, there are graph algorithms which identify the vertices sitting between communities, which can be very relevant, right? Think of project team here, project team there. If there is only one person connecting the two project teams, that person is actually pretty important, even though if this was a person here in the middle, has only two connections, it is a very important vertex in the graph as a whole. And there are graph algorithms, in this case, the between the centrality algorithm, for example, highlighting exactly those cases where there are vertices sitting between communities. Right? Or you can find outliers very nicely using graph technologies. And the way these graph databases work, or the way in which they are different from relational technologies, are in that they explicitly store the relationship, right? Unlike in a relational database where you have a primary key, foreign key relationship, you do a join, and then at runtime, you determine the connection. Here, we are explicitly storing the relationships. And that gives us the possibility to do very fast traverse, right? In the analytics world, graph databases are very popular these days. If you look at what the analysts say, in this case, Gartner, for example, for the last 3 years running, Gartner had graph databases among the top 10 data and analytics trends, and this is very recent. This is the 2021 trend. Number 8 is still graph, which is designed to specifically analyze relationships. So when we look at social networks like LinkedIn or the like, that is usually made up of networks which essentially just have one type of vertex. But graphs, in terms of modeling, go way beyond that. You can essentially represent anything as a graph. So the vertices, like here in the graph, they don't have to be identical. You can have a customer C who has bought a product A, which is manufactured by company B, which is sold by outlet F, using a promotion managed by a marketing company D. And so all these vertices, all these edges could have different meanings. They could have different properties, and also the relationships would be same thing, could be different, right? So you would find them not only in physical networks or social networks. You can also use them very nicely to analyze dependencies, right? Part hierarchies, or for the database administrators in the audience, right? If you have the DBA dependencies view, right, you have all these objects which depend on one another. That is something you can nicely represent as a graph, and then you can find out indirect relationships, right? Is this view which sits on top of a table which contains a column of a certain type, is there a connection between the view and the data type, and so forth? These are things you can do, or you can use them to model workflows. Some people use them to associate fragments of information into knowledge graphs, where you would maybe have a suspect in a police investigation who owns a car which was involved in a car crash with another car which belongs to a third person, and so forth. The main reason why graphs have become so popular is that they are not fixed in schema, right? Unlike in the relational world, where you would normally do a lot of upfront work doing your ER diagramming, your entity relationship modeling, and so forth. Here you can essentially start with pen and paper, and you can develop your model as you go along. And if you add new types of vertices, if you add, say, another property to a given kind of vertex, no problem. That doesn't break the rest. Your application still works, and the analytics in particular also still give meaningful results. So this kind of schema-less implementation is one reason why these things have become popular. Then, just already by visually representing the graph, you can already generate a lot of value. Just by looking at things, you can find out a lot if you have the intelligence sort of in front of the screen. But the main reason why graphs have become so popular is that they provide very powerful tooling for the analysis of relationships, looking at traversals, right? Is there a path between A and B? Is there a friend of a friend of a friend who's connected, and so on? And increasingly, and that's also reflected by this Gartner report, increasingly people are looking into combining graph analytics with machine learning, using the metrics you can compute by means of graph analysis as input to a machine learning platform. OML, for that matter, would be one option, right? Out in the real world, what do people do with this? Well, we've got a wide variety of use cases in the meantime. Quite a few of them are associated with customer 360 type of analysis or targeted marketing, where essentially you're not looking at the individual customer and his or her properties, but you're looking at how is this customer connected to another customer, maybe through a purchase they did or through some other behavioral pattern. So you can find similarities. You can use that for the purpose of, for example, product recommendation. And obviously that depends on looking at similarities. And if you can find things which are particularly similar, then obviously you can also use that to find things which are particularly different, which brings us to the topic of fraud prevention, for example, where you are using graph analysis for the purpose of anomaly detection, right? Finding those outliers, which, if you just look at the immediate properties of an object, are not immediately visible. But if you look at the context, if you look at how these things are indirectly connected, then you would find that there is something dodgy about it. And for example, in the context of graph pattern queries, you would be able to find fraud rings, right? Circular structures, money laundering, also where money is being transferred in a circle. That's typical things which you would identify by means of graph analysis. And the main reason why these things can be done so efficiently is that the relationship is a first-class object in the database, which can be taken into account for the analysis. The types of activities customers do with graph databases essentially falls into two buckets. On the one hand, there is the interactive, or mostly interactive, query processing, where if you have a given graph, you would usually find some kind of starting point, maybe a suspicious account where if you want to do fraud analysis, or a particularly important customer where you want to look at the environment of that customer. So you would start with a given vertex and then traverse the environment of the customer, following the connections, looking at the direct connections and then the connections of the connections, and so forth. Or that's the second bucket. The second class of application is you would execute graph algorithms, and there's a wide range of them, from shortest path to ranking to community detection, and so forth. We have actually been in that. We as Oracle, we've been in that space for a long time. The first graph implementations date back to Oracle 10G, so that's quite a while ago. This specific technology, which is also called property graph technology, which is a completely generic graph implementation, is something we've brought to market back in 2016. So it's been around for a while. Up to now, what you need to do is, if you want to use it locally, right, you install it on premises, or if you want to use it on the Oracle Cloud, maybe in conjunction with the Oracle Autonomous Database, what you would need to do, or what we would recommend you do, is, if you don't want to manually install things, use the OCI Marketplace image, download that, install that, and then use the tooling that comes with the product to run the kind of analysis in a notebook environment, or you can interact with the graph using the JShell client or a Python client if you prefer, and operate and maintain that whole environment like you would any other like you would do with any other on-premises environment, or what you would have on the Oracle Cloud as an application sitting on top of the database. That's what we had so far, but the announcement yesterday, which I was already referring to a little earlier, the announcement yesterday from Andy Mendelsohn, is now pointing to Graph Studio, which is a new tool which we have built into the Autonomous Database. As I said, at the moment it's in limited availability, and that tool gives you a complete self-service graph database and analytics environment as part of the Autonomous Database. And that means it's not only sitting on top of the Autonomous Database as such, meaning it makes use of the underlying database as the infrastructure, but it is also a completely managed environment from our side, which we provide to you, for you to do graph modeling, for you to do graph analytics using notebooks, including the built-in visualization. And of course, all of that sits on top of the graph analytics engine, which we've had out in the market for a couple of years already, as I said. And with this Graph Studio, we are essentially covering the entire workflow, which you would need to go from the relational world to deep insight into relationships using graph analysis, meaning we're providing tooling to map relational data structures to the graph, and we'll show you how that looks in just a moment. We will then guide you and provide tooling to move the data into the appropriate data structures and in-memory data structures in order for you to do the third step, which is the high-performance graph analytics and graph algorithms. And then we offer the notebook environment to actually document the work you're doing, collaborate with others, share the results, and then deploy the whole environment on the autonomous database. So that's the complete workflow. And if we look at that in a little more detail, go through these step by step, and then we'll show you what this looks like in the real world. I kind of assume that most of you are coming from a relational background. So most of you probably have a relational database with the appropriate entity relationship model in place. And so the first question obviously is, how do I get from a relational world to the graph? And we've made that increasingly easy with the existing on-premises tooling by providing a DDL type language, which allows you to describe the target model in a create property graph statement. But in order to make that even simpler for you, as part of Graph Studio, what we're offering now is a UI, which helps you and automatically suggests a target model. One quick remark about the graph model: unlike in the relational world, where you have a fixed theory behind this and a very rigid structure to things, here there's not only one solution to the problem. In fact, it is not at all uncommon to start with a first cut graph model and then refine as you go along, because the graph model, the data model you would use, depends on the analytics you want to do. But as I said, you're flexible. You can change things as you go along without breaking anything. From that perspective, graph analysis is a little more simple, or a little more flexible, let's say, than you would be otherwise. Now, in order not to go overboard with theory, what I would suggest is that we just show that in practice. Jayant, do you want to take over and briefly show what the graph modeler looks like in the real world?
Sure. Okay. If you want to stop sharing,
yeah, or you can
I can try and do that.
Yep, you can grab the share straight away if you want.
All right, let me start sharing, and you see my screen?
Yep, that looks good.
Okay, so Hans was talking about the fact that one of the things we've got here is a way for you to look at your existing data and then start modeling it as a graph, right? So for that, we've got this page called the models page, and you say, I want to create a model. It tells you what are the tables you've got. For example, I have access to the SH schema, which comes with every database, or I have some, or rather Hans has some data that has been loaded in his own schema, right? Let's say we want to take the sales history and create a graph from it. I want to omit, say, the demographics, and you select the tables of views that you want to model, and it's going to do what Hans mentioned, which is look at the existing metadata, the entities. The tables, for example, become vertices. Foreign key relationships are used to define the edges. Now, you can accept this as is, and you can see preview of what this would look like, which is, what are the edges and what are the vertices. You can also choose to go in and modify. So it gives you the create property graph statement. You can manually modify that from here, which may be quicker when you've got a lot of things that you want to get rid of. For example, a whole bunch of properties, or for that matter, even a table. If you happen to make a mistake, let's say, and let's make some syntax error here and see what happens. It's going to tell you that you made a mistake, and you can go back and say, well, discard these changes. Okay. So that is, just the basics of using this. You can, as I said, you can modify things by individually going in and removing things one by one at a time. You can preview, you can go to the source, and you can change things. But one of the things that you may want to do over here is this. I just took all the tables, right? I may have a particular use case in mind. Let's say all I want to do really is, I'm not trying to take all of the S8 schema. I simply want to do an analysis which says, I've got customers, I have products and sales. And as Han mentioned in his use cases, there are times when you just want to do, for example, in product recommendation, find out similarities. Who are customers who are similar? Which are the products that were bought together? And then do things like participate, help in a product recommendation workflow. So we take these, and in this case, it's going to inspect this and say, what you're essentially doing is you're looking at the relationship between products and customers, and a sale becomes the edge instead of being a vertex. So it figures out that this was a end-to-end relationship between products and customers. Once again, you can preview this, and it says this product was sold to this customer. If you want instead to model that as a product that a customer bought, you can click on this to swap the direction of the edge. And in that case, it's going to be customer bought this product. So that, in a nutshell, is what you can do with the modeling. There's obviously a few more things, and we have a set of workshops and labs that are published on the Live Labs platform that go into the specifics and the details of each one of these parts. So how to model, what to do with the graphs when you have them, and then we'll later talk a little bit about notebooks, and which is how do we analyze the graphs. So back to you, Hans.
Yeah, great. Thanks, Jayant. I think that gave a great overview, and we can skip over the screenshots because we've just seen those. Once we're done with the modeling, the next step then is to actually move the data into the appropriate data structures, right? So we're essentially using the Autonomous Data Warehouse, first of all, as a staging area. So we have the source tables, and then in the first step, we're moving, once we've done the modeling, the data into dedicated storage structures in the database. These are regular tables. That's one for all edges, one for all vertices, and they're regular tables. So you can enrich your data set. You can bulk load into these tables. You can do anything which you can do with SQL with these tables. And then in the next step, you can move them into the in-memory data structures, and that's where you would do the high performance, the root analysis, the community detection, all the algorithms, and the interactive analysis, right? That's where you would essentially do what Jane was already referring to just a moment ago, right? If you have this sales history schema, and you have your customers and your products connected through the purchased relationship, right? Every row in the customer table would become a vertex, every row in the product table becomes a vertex, and the edge, which is derived from the fact table, which was the sales table, then becomes an edge, which in turn carries properties. And then you can already see, right, this lady here in the middle has a similar behavioral pattern than the two gentlemen to the left and to the right. And from that, you can actually predict with a certain probability that she will also be interested in purchasing a product which the other two already have, right? These are the kind of things where by executing graph algorithms, product recommendation algorithms, community detection algorithms, all the things which we offer as part of the kit, you can run the analysis, and you can also use the interactive queries or the pattern matching queries to analyze specific environments. And the way you would do this is using a dedicated query language, because if you want to do pattern matching queries, you need to specify the pattern somehow, and SQL doesn't yet include this. We're actually working towards an extension to the SQL standard to cover that. But for the time being, and what goes into the proposal for the SQL extension is what we call PGQL, Property Graph Query Language. And as you can already see, right, the Property Graph Query Language is pretty similar to SQL, except it has a match clause that allows you to specify the pattern you're looking for. And anything referring to the vertex is in parentheses. Anything referring to the edge is either in square brackets, or there are also variants of that. So if we stick to the first query, that would essentially find all the vertices of type person, which a vertex of type person called Mario likes. So there's vertex of type person connected through a likes relationship, which is a directed relationship, as you can see from the arrow here, to another vertex, and it will find all the names of these vertices here. Now that's a very simple thing. Obviously you can do that with SQL very easily. What becomes a little more sophisticated is if you are trying to find all common ancestors of two given people, right? In PGQL, what you can do, rather than, what would you do in SQL? Obviously, you would use either the connect by prior, or you would use the recursive with these days mostly. What you can do in PGQL is actually extremely compact, and it looks like this. You could define a dedicated path as has parent as either has father or has mother, if they are separate relationships in your graph anyway, and then define a match clause which looks like this. You have a vertex of type person which is connected through a has parent relationship to a variable ancestor called ancestor, and the specific of that edge here is that it denotes one or more hops. So it doesn't necessarily mean this person connected to that variable ancestor, but it can be this person connected to another person to another person to another person, which is then connected to this ancestor. And we do the same thing for the second person with the same variable, and that will give us all the common ancestors. Right? This is just one example of showing the power of or the expressivity of the property graph query language. And as I said, the reason why we can do this very fast in graph databases is that we have materialized these relationships, so we can traverse them extremely quickly, right? And with that, we can combine the query language with the algorithms. Here's a list of algorithms which we already have in the product. Just a quick reminder on the machine learning ones. We've just released a few weeks ago, we've just released the 21.1 version of the Graph Server and Client Kit. That already includes 3 machine learning algorithms, which you may or may not have come across, depending on how much of a data science background you have, like deep walk or supervised GraphWise. These are, for the time being, part of the on-premises product. They will be taken up by the Graph Studio in the upcoming releases. They're just not there yet, right? And with that, you can use the platform which we provide, the notebooks which we have, to run these kinds of algorithms, to perform these types of queries. I don't know how much you've been using notebooks and notebooks and so on yourself in the past, but this is what we've built into the product. And rather than me talking about what they are, I think it's a good time for us to switch over to Jayant again, so that he can show you what this looks like in practice. Shall we, Jayant?
Sure. Let me start sharing again. Okay. So I'll use a simple notebook, which is taken some, we have some data of the bank accounts and transactions between them. This is fictitious data, but it's just to illustrate the point here. So one of the things that our customers have done with graphs is used it to look for patterns of in transactions or in transfers. So one of the patterns that they look for, or that they found when they're using graphs, is a pattern of circular transactions, which is a transaction originates at an account, is transferred through maybe 2, 3, or 4 other accounts, and then is finally deposited back in the original account. So they want to look for these patterns. That's the type of thing that you can do here. So we started with the model which had the bank accounts and the transactions, created a graph, and now we can do some analysis on them. And what notebooks do is they support, paragraphs that you execute. Each paragraph can be of a certain type. One is something called Markdown, which is just to document or annotate what you're doing. In this case, what is the purpose of this notebook? The other is PGQL. So execute PGQL statements and visualize the results. And the third is in order to run algorithms. So that is the Java. So in order to run algorithms such as PageRank or degree centrality or pathfinding, etc. So I'll quickly just give an example of what each one of these is. So the purpose here is we want to look at the graph and we want to find patterns of circular transactions. So why are we interested in this 934 first? Let's start with the basics in the graph. You look at the graph and just get a view of these. And somebody had the question, well, how can you visualize these? So there are different layouts. You can lay out, let's say, in a grid. You can lay out the results using force directed or any one of these layout schemes. But the first thing you want to do is which one of these accounts is, let's say, important in a certain sense. And let's say we say that the number of deposits into that account qualifies as it being important. So we run a query which says, I want to get the account ID and count the number of deposits in it and give me the top 10. And that's how we see that a lot of deposits into this account 934. And then that's the one that we're interested in. We want to examine a little further. The first step is, do we have any circular payments? So this is Hans was giving, when he was giving the example of the ancestors, he talked about the fact that you can have specify a path of any length. In his case, he used the plus, which says 1 or more. In here, I'm saying specifically a path of length 5 that starts and terminates at the same node. And we say they are indeed. So let's look at what they are. So we explicitly say, I want to see the last, that is the account that made the deposit, so that I get some sense of how many such transactions there are. So this was a path of length 5. We can do the same with of length 6. So any path of length 5 followed by a deposit into that account. Right? So we've done this, and this gives us some information, but we also may want to look at exactly what were the transactions that were taking place. So I can enumerate the full path and then view it in this hierarchical way, which makes it easy for me to see that it originated here, went to this account, into this one, into this next third one here, and then back. So looking at a different visualization, a hierarchical visualization in this case. Now we've done that, but what we are interested in is seeing we had one notion of importance, which was how many deposits. But graphs also have other notions of importance, not just degree centrality, is page rank. So I could, for example, I am going to have to execute this, is load the graph, run this algorithm, and then run the same query, find all paths, of length 1 to 6 on this graph. And then we can visualize it based on the page rank value. So the ones with a high page rank value are visualized with a larger symbol for the vertex or for the account. So let's look at how that relates to our earlier notion. Our earlier notion was, I'm saying in this case, I've taken, the degree, in degree and out degree, which means deposits in and transfers out. Now look at the top 10. This is one way to say, this is the list. I look at the list based on page rank. It's similar. Many of them are in common. 934 is here, 135 is there, etc. But there are some, for example, 4, which shows up here, 380, which show up here. So why is it that 4 is showing up as important in terms of page rank? 380 has lots of transfers, either incoming or outgoing, but doesn't show up. So we can look at that too and take a look at that. So find out what are the transactions in which account 4 is involved, what are the transactions in which 380 is involved, and you see the difference between the two. 380, while it has a lot of transfers, it's all to other accounts that don't have a high page rank. 4, on the other hand, has transfers, either incoming or outgoing, to accounts that do have a high page rank, which means they're also highly connected. And in fact, 4 is connected to, there was a transfer to an account, which then made a transfer to 380. So it's also close to 380, which has a high page rank, which is why 4 has a high page rank and shows up on this list, and 380 doesn't. Now, what does that mean? Then Hans, you want to talk about your examples from the banking customers that did the customer 360, looking at things from a perspective of important customers in terms of churn, important customers in terms of number of transactions.
Yeah, I mean, this could actually be meaning two things, right? You could either use this kind of analysis to identify those customers who are executing a lot of transactions, which, if you pay per transaction, are important as such, and you want to make sure that they're happy. In that case, you may want to make sure that also people who are close to people who are executing many transactions are treated specially, just so that you're not messing with, let's say, the son of a very important customer in order not to upset his father so that he decides to move to another bank. This could be one aspect. It could also mean that if we have a scenario in fraud detection, that we have a vertex where many activities are taking place, and another vertex, like 4 in this case, another vertex like 380, where a lot of activities are taking place. And behind these two, there may be the same person controlling all of that, who only gets occasional transfers out of these accounts, but who is the head behind fraudulent activity. So there can be a lot of interpretations associated with it. I'm not going to go into the sort of the domain specifics here, but I hope it's giving you at least a bit of an idea of where the power of graph analytics lies and what you can do with it. You've seen the notebook environment. Just one quick remark on the whole automation and of the environment. Right, there's really not much you need to do. This is all part of the autonomous database. Will take care of the installation, the operations, the maintenance, all of that. The in-memory analytics engine in particular, you have a little bit of control, but again, we can take care of that as well. So there's really not much you need to do. Right. As part of the limited availability program, we've had a bunch of customers already testing these features, and we got a lot of positive feedback. Like this case from Immediately in Japan, who are emphasizing the scalability, and that was one of the key decision criteria for them to work with our technologies. Datalysis have made very positive experience with the ease of use, just because it lowers the threshold. Graph Studio just lowers the threshold of getting started. Dan and Tim Blamis have been trying out Graph Studio, and they are particularly excited about the graph algorithm. So lots of positive feedback from the technologies already during limited availability. If you would like to join the limited availability program, do get in touch with us. We have posted a blog post on the Database Insider blog where you can find a dedicated email address which you can use to request access, or you can contact just Jayant or myself if you would like to get your hands onto this technology. And just to wrap up, I hope in the 45 minutes we've given you a bit of an idea of what graph databases are about in the first place. They're particularly useful if you are looking at connectedness of objects, so that graph analytics gives you information about relationships, about dependencies, about behavioral patterns. And the topic which we haven't really touched on is that you can use that very nicely also in conjunction with machine learning, and we'll certainly do a dedicated Ask Tom session on that topic in the near future. Graph Studio, you've seen it now, you have an idea of how it works. Basic idea is we offer end-to-end tooling so that you can model your relation data as a graph, you can manage the graph in the database, you can use the environment to query and analyze the graph, you have a notebook to do the visualization and the collaboration with others, and then all of that sits on top of the graph analytics engine, which you know and love, with all its 60 plus pre-built algorithms and the PGQL query language. Right, this webcast was just to give you a little bit of insight. If you are interested in more and you want to try things out in practice, the next thing we can offer in terms of hands-on workshops is the Techcast Days, and I may be stealing Edel's thunder here. She already mentioned we have the Techcast Days in May coming up. There is a dedicated day of workshops on May 12th already. The format is a little different than what we did with Techcast Days with the A&D OUC team in the past, in that it'll be more interactive, it'll be more hands-on oriented. All of that will be using Graph Studio on the autonomous database. That'll be one half, the other half will be Spatial Studio, but that's not the focus of today's topic. And the analytics and data Oracle user community is just great to learn from others, to network with others, and in this case with the Techcast Days, we'll give you the opportunity to also try out the latest stuff which we have, or you can find more information here. Right, and I think we'll leave it at that and move on to Q&A if there are still any open questions. I have noticed that Jean and Melly have already been busy answering things as we went along.
They were doing an amazing work answering all the questions. I think that there is one that I think Cheyenne and Melly also already answering about the the lab with graph visualization. Yes, they already answer all the questions. I don't know. We can have like one more minute if someone else wants to ask any other question. So
while people are still while
Yes.
people are still thinking, there was one question which I sort of saw flying by, and I don't know if and how detailed it's been answered. There was the question, the usual question of, what if my graph is too big? And that's of course a very, very valid question, right? Unlike other sort of pure graph databases, what we're doing is we have the distinction between the graph data store, which is sort of the persistent storage layer in the autonomous database, which essentially takes care of a graph of arbitrary size. And now for the in-memory data structures, obviously you're limited, you're constrained by the amount of memory you have. And in order to cope with that, we have the possibility to just work with subgraphs in order to make things fit. You can still use the full graph you can still store the full graph in the persistence layer, but you would only use a subgraph in memory, run the analytics there, and that can make things fit. It may actually also be an idea to just use the structure of the graph rather than all of its, particularly in data warehousing, where you have lots of properties on each vertex, many of which are maybe text, which you don't really want to use in graph analysis when you're looking at connectedness. So you can drop all of that and just look at the raw structure, and then you can use billions of vertices in a relatively small environment for the kind of analytics which you would normally want to do. So that does cover, hopefully, the question about memory. Yes.
Yes, and I think it's important to highlight that it's great that we have it right now in Autonomous, but we already have Graph Studio on-prem. I think that there were many questions related with that. Maybe you can highlight that the on-prem option too.
Yeah, that's actually a good point, and thanks Edel for specifically emphasizing that. We have had our on-premise offering for years. In the on-premise offering, we also provide the visualization, we provide notebooks. What we do not have, and that's also important to point out, what we do not have on premises is the modeling piece. That is something which is really closely tied to the autonomous database environment. And obviously, in the autonomous database environment, we're taking care of all the management and the maintenance and the administration and so forth. So unlike the user-managed on-premise or the user-managed offering in conjunction with the autonomous database using, say, the OCI marketplace image. So it was good you mentioned that. I just saw one more question flying by, and I thought it would also be a good opportunity to briefly touch on the topic of Oracle Analytics Cloud, because that was the last question I briefly saw, and I know that there has been quite some interest in this topic due to the upcoming OAC version 6 release. So quick comment on that. OAC version 6 is planning to include graph analysis as well, and that is sitting on top of the graph capabilities we offer in the database, but it cannot use the in-memory data structures. It just uses the graph features in the database, which is great for a certain number of use cases. It is excellent if you have a graph which is maybe not as huge, or you have don't have too complex analysis which you want to execute, but all the in-memory functionality, and in particular the algorithms, with the exception of 5 algorithms which we have also available in the database. All of the algorithms are only accessible if you use the Graph Server and Client Kit in conjunction with OAC or Graph Studio in autonomous database. I hope that made it a little clearer, and I didn't cause too much extra confusion here.
No problem. It was very clear. It was a great session. Thank you so much, Hans and Jayant, for this. And thank you also to Shin and to Meli for the assistance with all the questions. And people, if you want to, if you don't see all the recording, all the session, the recording is going to be available today, later. Just check our website and our YouTube channel. Thank you all for attending this session, and have a great day.
Thanks a lot. Also from my side, Edel, thank you very much for moderating. Thank you.
Thank you. Bye-bye.